Hello everyone, welcome to Creative Civil Engineering Coach. In this video, I will be discussing about PGCET Civil Engineering question paper of the year 2010, and I will be providing the complete analysis and detailed solution for this question paper. So let's begin with the part 1 questions. Question number 1. For any system of coplanar forces to be in equilibrium, algebraic sum of horizontal components of all the forces should be equal to 0. That is, summation of fx is equal to 0, and algebraic sum of vertical components of all the forces should be equal to 0. That is, summation of fy is equal to 0, and algebraic sum of moments of all the forces about any point should be equal to 0. That is, summation of moments is equal to 0. So all these statements are correct. Option D is the right answer, all of the above. Question number 2. The bending moment at a beam cross section where shear force is 0. So consider a simply supported beam AB of span length L with UDL load intensity W kN per meter. For this simply supported beam, the shear force diagram will be like this, and the bending moment diagram will be like this. When the shear force is 0, the bending moment at the midspan of the beam will be maximum. So option B is the right answer. When the shear force is 0, the bending moment at a beam cross section will be maximum. Question number 3. The statement that a plane section of a bar under twisting before the application of twisting moment remains plane after the application of twisting moment is valid for. This statement is valid for only circular cross sections, hollow or solid type. So option D is the right answer. Plane section remain plane before the application of twisting moment and continue to remain plane after the application of twisting moment only in the circular cross sections. So option D is the right answer. Question number 4. A prismatic beam fixed at both the ends carries uniformly distributed load over the entire span. The ratio of bending moment at support to the bending moment at midspan is. Consider a prismatic beam fixed at both the ends of a span length L with uniformly distributed load W kN per meter, and the bending moment diagram for this prismatic beam is like this. The bending moment at support is WL square by 12, and bending moment at midspan of the beam is WL square by 24. Now the required ratio of bending moment at support is WL square by 12 divided by WL square by 24. This is bending moment at midspan. On solving this, you will get the ratio as 2. So option D is the right answer. Question number 5. The mortar in which both cement and lime are used as binding material is called gauge mortar. Gauge mortar is also called as lime cement mortar, where the major principal constituents are cement and lime. So option C is the right answer. Question number 6. For a water cement ratio of 0.6, the water content per bag of the cement is. Given that water cement ratio is 0.6, to find the water content per bag of the cement, water content will be 0.6 times of quantity of cement. Therefore, cement will be 50 kg per bag. So 0.6 multiplied by 50, water content will be 30 kg. So option C is the right answer. Question number 7. A roof which slopes in 4 directions is called. A roof sloping in 4 directions is called hipped roof. Option C is the right answer. Shed roof is a roof where slopes spanning in one direction. Gable end roof is a roof which slopes in two directions. Gambrel roof is a type of roof which slopes in two directions, but there will be break in slope. So, a roof which slopes in 4 directions is hipped roof. Question number 8. The formwork for the sides of the reinforced concrete beam can be removed only after, as per IS 456-2000 codal provisions from the clause 11.3.1, there are certain guidelines to be followed for curing period. That is, for vertical formwork, the minimum curing period is 16 hours to 24 hours, and for soffits, slabs, the minimum curing period is 3 days, and for beams, the minimum curing period is 7 days. So here they are asking for formwork for the sides of reinforced concrete beam. So these are the vertical formworks. So it will be around 1 day. So option A is the right answer. Question number 9. The number of treads in a flight is equal to. Number of treads is equal to number of risers minus 1. So option C is the right answer. Question number 10. If the smallest division of a vernier is longer than smallest division of primary scale, then the vernier is known as. The direct vernier the main scale divisions is n minus 1, and in retrograde vernier the main scale divisions is n plus 1, and in extended vernier the main scale division is 2n minus 1. Since if the smallest division of vernier is longer than smallest division of its primary scale, so here they are talking about retrograde type of vernier. So option C is the right answer. Question number 11. Locating the position of plane table with reference to 3 known points is known as. To locate the station occupied by the plane table given by the position of 3 points, it is called as 3-point problem. Option D is the right answer. Question number 12. An ideal vertical curve to join two gradients is. Ideal shape for summit curve or vertical curve is circular type. However, if the deviation angle is very small, behavior of parabola and circular is same. So, it is same as parabola or circular. Hence, parabola is preferred for summit curve. Option B is the right answer, that is parabolic type of curves. Question number 30. Equation of continuity of the flow is based on the principle of conservation of. Continuity equation is based on the principle of conservation of mass. Option A is the right answer. Thus, for a fluid flowing through pipe at all cross section, the quantity of the fluid flowing per second is constant. That is, rho 1 A1 V1 is equal to O2, A2 and V2. So option A is the right answer. Question number 14. Hydraulic radius is equal to. Hydraulic radius is the ratio of wetted area by wetted perimeter. So area divided by wetted perimeter is the right answer. Option B is the right answer. Question number 15. Shear span is defined as a zone where. Shear span is defined as a span between the points of application of concentrated load to its adjacent reaction force in the beam. So, shear span is defined as a zone where shear force is constant. Option C is the right answer. Question number 16. The characteristic strength of concrete as per IS 456 defined as the compressive strength below which not more than 5% of the test results will fall. Option B is the right answer. According to IS 456-2000, not more than 5% of the results are expected to fall, that is, not more than 1 in 20 test results should fall below this characteristic value. Question number 17. The permanent deformation of concrete with the time under sustained load is called creep. Option A is the right answer. Creep, it is a type of long-term pressure or stress on concrete due to which there is change in shape of the concrete structure. Option A is the right answer. Question number 18. In a singly reinforced beam, the effective depth is measured from its compression edge to central of the tensile reinforcement. So option B is the right answer. Question number 19. An RC T-beam behaves as a rectangular beam of width equal to flange width if its neutral axis is. Consider a T-beam. So, in case of T-beam, if the depth of neutral axis lies within the flange region, then there is sagging bending moment, then only the portion below this neutral axis will lie in tension, and hence it is neglected. Therefore, T-beam will behave as a rectangular beam having width equal to flange width. So option A is the right answer. Remains within the flange. Question number 20. The shear reinforcement in a reinforced concrete is provided to resist. Shear reinforcement is provided to take up the diagonal tension and prevent cracking of the beam. Option C is the right answer. Diagonal compression. Question number 21. A column splice is used to increase length of the column. Option A is the right answer. Column splice are mainly used when the columns are subjected to bending and when the available length of the structural steel section is less than the required length of the column. Hence, column splice are used to increase length of the column. Option A is the right answer. Question number 22. The method of design of steel framework for greatest rigidity and economy in weight is known as. This method of design of steel framework for the greatest rigidity is fully rigid design. Option C is the right answer. Question number 23. If the coefficient of active earth pressure is 1 by 3, then the coefficient of passive earth pressure is. We know that coefficient of active earth pressure is calculated by the formula 1 minus sin phi divided by 1 plus sin phi. And coefficient of passive earth pressure is 1 plus sin phi divided by 1 minus sin phi. And the relation between coefficient of active earth pressure and coefficient of passive earth pressure is Ka is equal to 1 by Kp. Therefore, to find the value of coefficient of passive earth pressure is given by 1 by 3. So, coefficient of passive earth pressure will be 3. Option B is the right answer. Question number 24. The ratio of settlement of soil at any time t to the final settlement is known as consolidation of undisturbed soil. Option D is the right answer. And consolidation of undisturbed soil is given by formula U percentage is equal to H divided by H multiplied by 100, where H is the settlement at any time and capital H is final settlement at the end of the consolidation of soil. So option D is the right answer. Question number 25. Compression of soil occurs rapidly if the voids are filled with A. Option A is the right answer. Question number 26. At a point in a loaded soil medium, the normal stress is maximum on. So the normal stress is maximum on major principal plane. Option C is the right answer. Question number 27. Toughness index of soil is the ratio of. Toughness index is the ratio of plasticity index by flow index, and the range of toughness index varies from 0 to 3, and this toughness index gives an idea of shear strength of soil at its plastic limit. So it is the ratio of plasticity index to the flow index. Option D is the right answer. Question number 28. Which one of the following is taken into consideration while determining its overtaking side distance in 4-lane highway? While determining the overtaking side distance in a 4-lane highway, reaction time plus overtaking distance is considered. Option C is the right answer. Question number 29. Length of the vehicle affects extra width of the pavement and minimum turning radius. Option B is the right answer. Question number 30. In which of the following traffic signal system are the cycle length and cycle divisions are automatically varied? The cycle length and cycle divisions of the traffic signal system are varied automatically in flexible progressive system. In this system, it is possible to automatically vary the length of cycle division and the time scheduled at each signalized interval or intersection with the help of computer. Option D is the right answer. That is flexible progressive system. Question number 31. Dunkelman beam deflection method is used in the design of flexible overlay on flexible pavement. Option B is the right answer. This Dunkelman beam deflection method is used for evaluation of structural capacity of existing flexible pavements and also for estimation and design of flexible pavement overlays for the strengthening of any weak pavement for highways. This Dunkelman beam deflection method measures the deflection of flexible pavement under moving load, and the overlay thickness of the flexible pavement is calculated by the formula 550 log E dc by dA, where dc is the corrected deflection of the flexible pavement and dA is the actual deflection of the flexible pavement. So option B is the right answer. Question number 32. Which of the following represents carpet of sand bitumen mix without coarse aggregates? Sheet asphalt represents the premix of bitumen and sand with or without filler and containing coarse aggregates that exceeding 30% lead in thickness. So option B is the right answer. Question number 33. Standard broad gauge width is. As per IRC, the standard broad gauge width is 1.676 meter. Option C is the right answer. This broad gauge is commonly known as Indian gauge and it is also called as dominant track gauge in India. Question number 34. The hauling capacity of locomotive depends upon. Hauling capacity of a locomotive is calculated by mu Wn, where mu is the coefficient of friction, W is the weight exerted on driving wheels, and N is the number of pairs of driving wheels. So, hauling capacity of locomotive depends upon load on the driving wheel and friction and number of pairs of driving wheels. So, it is both A and B. Option C is the right answer. Question number 35. Of the following, select the correct statement. Statement A. Traffic volume should always be more than traffic capacity. This statement is wrong, since traffic volume should always be lesser than traffic capacity. Statement B. Traffic capacity should always be more than traffic volume. This statement is also wrong, since traffic capacity should always be lesser than traffic volume. Statement C. Spot speed is the average speed of the vehicle at specified section. This is correct statement. Statement D. 85th percentile speed is more than 98th percentile speed. Since 98th percentile speed is greater than 85th percentile speed, option D or statement D is also wrong statement. So the correct statement is option C. Spot speed is the average speed of the vehicle at a specified section. Question number 36. Rainfall mass curve shows the variation of. Rainfall mass curve shows the variation of cumulative rainfall with time. Option D is the right answer. In hydrology, there are hydrological curves, that is mass curve is the variation between cumulative rainfall versus time. Double mass curve is the variation between cumulative rainfall of nearby versus cumulative rainfall of concerned section. Hydrograph is the variation between discharge versus time, and hydrograph is the variation between rainfall intensity versus time. These are the important hydrological curves. Question number 37. A linear reservoir is one in which storage varies linearly with outflow rate. So option B is the right answer. Question number 38. If the intensity of rainfall is more than the infiltration capacity of soil, then the infiltration rate will be equal to infiltration capacity. Option B is the right answer. Question number 39. The statement that the ordinate of direct runoff hydrograph of a common base period are directly proportional to volumes of runoff represented by the respective hydrograph is known as principle of linearity. Option A is the right answer. Question number 40. A deep well A deep well has a more discharge than shallow well. Option C is the right answer. Question number 41. The duty of the crop is 432 hectares per cumex and the base period of the crop is 100 days. Then delta of the crop will be in centimeter. We know that the relation between duty, delta and the base period is given by delta is equal to 8.64 B by D. So we have to find the delta. Base period is given as 100 days and duty is 432 hectares per cumex. So if you calculate this, you will get the delta of the crop as 200 centimeter. So option B is the right answer. That is 200 centimeter. Question number 42. The uplift pressure on the face of the drainage gallery in a dam is equal to. The uplift pressure on the face of drainage gallery in the dam is equal to 2/3 of the hydrostatic pressure at toe plus 1/3 of the hydrostatic pressure at heel. Option C is the right answer. Question number 43. The overfall of a spillway in a shape of double or S curve which is convex at the top and concave at the bottom is called. This type of spillway is called as Hoggy spillway. Option A is the right answer. That is Hoggy spillway. In this type of the spillway, the shape of the Hoggy at a downstream face of the weir based on the principle of projectile, and the section of Hoggy type of the spillway is like this, where convex shape will be at the top of the spillway and concave shape at the bottom of the spillway. So this is the type of Hoggy spillway. Option A is the right answer. Question number 44. The most suitable section of a lined canal is. The most suitable section of a lined canal is option C. That is triangular section with circular bottom for small canals and trapezoidal section with rounded corners for large canals. So both A and B will be the right answer. Number 45. Blitzkrieg theory assumes that the percolating water follows the outline of the base of the structure which is in contact with subsoil, and according to Blix, the hydraulic gradient is defined as head loss divided by length of the creek. And the coefficient of creep is given by reciprocal of hydraulic gradient, that is L by H. Option A is the right answer. That is percolation water creep is along the contact of the base profile of the apron with subsoil. Question number 46. Aeration of water is done for the removal of. Aeration brings water and air in close contact in order to remove the dissolved gases CO2 and oxidizes the dissolved metals such as iron, manganese, hydrogen sulfide and volatile organic chemicals. So option D is the right answer. That is, it is mainly done to remove of odor. Question number 47. An earth formation which, although porous and capable of absorbing water, does not provide an appreciable supply to wells is known as aquiclude. Option B is the right answer. It is a geological formation which is impermeable to the flow of water. It contains a large amount of water in it but does not permeate through it and does not yield water due to the high porosity. Example, clay. Clay is a material which is capable of absorbing water but does not provide an appreciable supply of wells. So it is called as aquiclude. Option B is the right answer. Question number 48. In septic tanks, decomposition of organic bacteria is done by anaerobic bacteria. Option A is the right answer. Question number 49. In water distribution pipes, air valves are provided at. Air valves are also called as air relief valves, Water flowing through the pipes always carries some air with it. This air accumulates at summit of the pipeline and causes backward pressure. So, to get rid of accumulated air, these air walls are mainly provided at lower points. Option A is the right answer. Question number 50. Biochemical oxygen demand BOD of a safe drinking water should be nil. BOD represents the amount of organic matter present in water. So there should not be any BOD in the safe drinking water. So it should be nil. So this completes the part 1 questions of this question paper.
Now let's begin with the part 2 questions. Question number 51. The principal stress at a point in a loaded material are 80 MPa, 30 MPa and minus 40 MPa. The maximum shear stress at a point is. To find the maximum shear stress, tau max is equal to sigma 1 minus sigma 2 divided by 2, where sigma 1 and sigma 2 are major and minor principal stress. 80 minus of minus 40 divided by 2, that is 80 plus 40 divided by 2 is equal to 60 MPa. So the maximum shear stress is 60 MPa. Option D is the right answer. Question number 52. What is the safe stopping side distance for a design speed of 50 kmph, two-way traffic on a two-lane road, assuming coefficient of friction as 0.37 and reaction time as 2.5 seconds? As per IRC, the safe stopping side distance is given by the following formula, that is Vt plus V square divided by 2gf, where V is the design speed of the vehicle, that is 50 kmph. We have to convert this design speed into meter per second. So 50 multiplied by 5 by 18. So the design speed will be 13.9 meter per second. T is the reaction time, 2.5 seconds. G is the acceleration due to gravity, that is 9.81 meter per second square. And F is the coefficient of friction, 0.37. By substituting these values in the above formula, safe stopping side distance is 13.9 into 2.5 plus 13.9 square divided by 2 into 9.81 into 0.37. On solving this, the safe stopping side distance is 61.36 meter. So option B is the right answer, 61.4 meter. Question number 53. The maximum bending moment induced in a simply supported beam of a span 5 meter and carrying uniformly distributed load of intensity 10 kN per meter is. So we have to find the maximum bending moment induced in simply supported beam. Consider a simply supported beam of a span length 5 meter with UDL intensity of 10 kN per meter. The maximum bending moment for the simply supported beam is given by the formula WL square divided by 8. W is the intensity of the load, that is 10 kN per meter. L is the span of the beam, 5 meter, so 5 square divided by 8. If you calculate this, the maximum bending moment will be 31.25 kN meter. So option A is the right answer, that is 31.25 kN meter. Question number 54. For a certain material, the Young's modulus is 200 GPa and the modulus of rigidity is 80 GPa. The value of the Poisson ratio is. From the elastic constant relation is equal to 2g into 1 plus mu. E is the Young's modulus, G is the modulus of rigidity and mu is the Poisson ratio. Young's modulus is 200 GPa, so 200 into 10 to the power of 3 is equal to 2 into G. G is the modulus of rigidity, that is 80 MPa. 80 into 10 to the power of 3 into 1 plus mu. Mu is the Poisson ratio we have to find. By solving this, 200 into 10 to the power of 3 divided by 2 into 80 into 10 to the power of 3, you will get 1.25 is equal to 1 plus mu. Therefore, mu is equal to 1.25 minus 1. So, Poisson ratio will be 0.25. Option C is the right answer, 0.25. Question number 55. The shear force on a rectangular beam section 200 mm into 400 mm is 10 kN. The maximum shear stress induced is, as per IS 456-2000 codal provisions, the maximum shear stress induced in the rectangular beam is given by tau max is equal to Vu divided by area of the cross section. That is, for rectangular cross section, it is B into D. Vu is the total shear force 10 into 10 to the power of 3 divided by BD is the area of the rectangular cross section 200 into 400 mm. Therefore, the maximum shear stress induced in this section is 0.125 MPa. So, option C is the right answer. Question number 54. For a cantilever beam of a span 2 meter carrying a UDL of 2 kN and a point load of 10 kN at the free end, the maximum bending moment induced is. So, let's consider a cantilever beam of a span length 2 meter with UDL intensity of load 2 kN and a point load at free end of 10 kN. Now we have to find the maximum bending moment. Maximum bending moment is given by the formula W x square divided by 2 minus WL by 4. By substituting the values of intensity of UDL load and point load and the span length of the beam in the following formula, the maximum bending moment will be 4 kN/meter. So option C is the right answer, 4 kN/meter. Question number 57. A solid circular shaft is subjected to pure torsion. The ratio of maximum shear stress to maximum normal stress at any point is. For a solid circular shaft subjected to pure torsion means sigma x and sigma y will be equal to 0. Therefore, the maximum shear stress will be tau and the maximum normal stress will be tau. Therefore, the ratio between tau max and normal stress will be 1:1. Therefore, option A is the right answer, 1:1. Question number 58. An axially loaded RC column of effective length 3 meter has a cross section of 300 mm by 300 mm. The minimum eccentricity of load that must be allowed in the design as per IS 456-2000 is. As per IS 456-2000, the minimum eccentricity of load for an axially loaded RC column is given by the following formula, that is E minimum is equal to minimum of Lx divided by 500 plus B divided by 30 or Ly divided by 500 plus D divided by 30. Lx is equal to Ly, that is effective length of the column along x axis is equal to effective length of column along y axis, that is 3000 mm, that is 3 meter. B into D is the cross section of the RC column, that is 300 mm by 300 mm. Since breadth of the RC column is equal to depth of the column, that is 300 mm, the minimum eccentricity is calculated as E minimum is equal to Lx divided by 500 plus B by 30. Lx is effective length of the column 3000 mm divided by 500 plus B is the breadth of the cross section of RC column 300 by 30. So minimum eccentricity will be 16 mm. So option C is the right answer, 16 mm. Question number 59. A circle of radius 7 meter has a standard error of 0.02 meter on the radius. The standard error of its area is. So we have to find the standard error of area. EA is equal to ER multiplied by 2 pi R. Error of the radius is 0.02 meter multiplied by 2 pi R. R is the radius of the circle, that is 7 meter. So if you calculate this, error of the area will be 0.88 meter square. So option D is the right answer. Question number 60. The allowable bearing capacity at 25 mm allowable settlement for a footing in a sandy soil is 15 kN per meter square. The allowable bearing capacity for the same footing permitting a settlement of 40 mm is. So For 25 mm allowable settlement, bearing capacity Q1 is equal to 15 kN per meter square. And for 40 mm allowable settlement, the allowable bearing capacity Q2 we have to find. Bearing capacity Q1 divided by allowable settlement delta 1 is equal to bearing capacity Q2 divided by delta 2. Q1 is 15 kN per meter square divided by 25 is equal to Q2 we have to find. Delta 2 is 40 mm. Therefore, Q2 is equal to 40 into 15 divided by 25. 5 3s are 5 5s are 5 8s are. Therefore, 8 3s are 24 kN per meter square. Therefore, for a settlement of 40 mm, the allowable bearing capacity is 24 kN per meter square. Option A is the right answer. Question number 61. In a saturated soil deposit having a density of 22 kN per meter square, the effective normal stress on a horizontal plane at 5 meter depth will be. So, effective stress is given by total stress minus pore water pressure. Total stress is density of soil multiplied by depth minus density of water gamma W multiplied by depth of the pore water pressure. Density of soil is 22 multiplied by depth of the total stress is 5 meter minus density of water is 10 and depth of the pore water pressure is 5 meter. Therefore, if you calculate this, the effective stress will be 60 kN per meter square. So option C is the right answer. Question number 62. A clay sample has a void ratio of 0.54 dry state. The specific gravity of the soil solid is 2.7. The shrinkage limit of the soil is. So we have to find the shrinkage limit of the soil. We know that unit weight of the soil in dry state divided by wet unit weight is equal to G divided by 1 plus E. G is the specific gravity of the soil solid, that is 2.7 divided by 1 plus E. E is the void ratio, that is 0.54. So let's consider this as R, that is the ratio between the unit weight of the soil in dry state by wet state. Therefore, if you calculate this, the ratio will be 1.753. Shrinkage limit is given by the formula 1 divided by R minus 1 divided by G. 1 divided by R is 1.753 minus 1 divided by G. G is the specific gravity of the soil solid 2.70. Therefore, if you calculate this, shrinkage limit will be 0.2, that is 20%. So option D is the right answer. Question number 63. When the water surface coincides with the top edge of the rectangular vertical gate 40 meter wide by 3 meter deep, then the depth of the center of pressure is. So let's consider a rectangular vertical gate of 40 meter wide by 3 meter deep. So we have to find the depth of center of pressure. So let's consider this as a center of pressure in the vertical gate. So the depth of center of pressure is given by 2D divided by 3, where D is the depth of the vertical gate. So 2 into 3 is the deep of the vertical gate divided by 3. So depth of center of pressure will be 2 meter. So option C is the right answer. Question number 64. The normal annual precipitation at a station X, A, B and C are 700 mm, 1000 mm, 900 mm and 800 mm respectively. If the storm precipitation at the three stations A, B and C were 100 mm, 90 mm and 80 mm respectively, then the storm precipitation for station X will be. So we have to find the storm precipitation at station X. It is given by the formula Px is equal to Nx divided by 3 into P1 divided by N1 plus P2 divided by N2 plus P3 divided by N3. It is equal to Nx is the normal annual precipitation, that is 700 mm divided by 3. P1 is the storm precipitation. So at station A, it is 100 mm divided by normal annual precipitation for station A is 1000 mm. 100 divided by 1000 plus 90 divided by 900 plus 80 divided by 800 mm. So if you calculate this, the precipitation at station X will be 70 mm. So option A is the right answer, 70 mm. Question number 65. A city supply of 15,000 meter cube of water per day is treated with chlorine dosage of 0.5 parts per million. For this purpose, the requirement of 25% of bleaching powder per day would be. So we have to find the amount of bleaching powder per day. So quantity of bleaching powder is equal to water supply, that is 15,000 meter cube, multiplied by chlorine dosage, that is 0.5 into 10 to the power of minus 3, divided by, for 25% of bleaching powder means 25 divided by 100. So quantity of the bleaching powder will be 30 kg. So option C is the right answer. Question number 66. Question number 66. If the deoxygenation coefficient of a stream at 20 degrees Celsius is 0.1, then the value at 22 degrees Celsius will be. Deoxygenation coefficient Kd is equal to 0.1 at 20 degrees Celsius. Deoxygenation coefficient at 22 degrees Celsius we have to find. We know that to find the deoxygenation coefficient at different temperatures, Kd 22 degrees Celsius, K 20 degrees Celsius multiplied by 1.056 to the power of T minus 20. So K 20 degrees Celsius is 0.1 multiplied by 1.056. T is 22 degrees Celsius, 22 minus 20. On solving this, the deoxygenation coefficient at 22 degrees Celsius, you will get the answer as 0.115, that is nearly equal to 0.120. So option A is the right answer. Question number 67. If the present population is 47,000 and the average increase in population is 5,500, then the future population after one decade by arithmetic increase method is. According to arithmetic increase method, the population for future after one decade is calculated by the formula Pn is equal to P0 into 1 plus n into x bar, where n is the number of the decades, that is one decade, x bar is the increase in the population, that is 5,500, and the present population P0 is equal to 47,000. By substituting these values, population of future after n decades, that is after one decade, present population is 47,000 multiplied by 1 plus n is 1 decade and x bar is 5,500. Therefore, population after one decade will be 52,500. Option A is the right answer, 52,500. Question number 68. In a BOD test, 1 ml of raw sewage was diluted to 100 ml and the dissolved concentration of diluted sample at the beginning was 6 parts per million and it was 4 parts per million at the end of 5-day incubation at 20 degrees Celsius. The BOD of the raw sewage will be. So we have to find the BOD of the raw sewage, that is BOD of raw sewage is equal to initial dissolved oxygen content minus final dissolved oxygen content multiplied by dilution factor. Initial dissolved oxygen content is 6 parts per million, that is 6 minus, and final dissolved oxygen content is 4 parts per million, so 6 minus 4 into dilution factor. So 1 ml of raw sewage is diluted into 100 ml. Therefore, the dilution factor will be 100 divided by 1. If you calculate this, the BOD of the raw sewage will be 200 ppm, that is 200 parts per million. So option B is the right answer. Question number 69. If the area of the drainage is 200 hectares, intensity of rainfall is 40 mm per hectare and the coefficient of runoff is 0.44, then the runoff water discharge by rational method. So we have to find the runoff water discharge by rational method. According to rational method, to find the discharge, Q is equal to CIA, where C is the coefficient of runoff, that is 0.44, I is the intensity of the rainfall 40 mm per hectare, that is equal to 40 divided by 1000, and A is the area of the drainage, that is 200 hectares. So 200 into 10 to the power of 4. By substituting these values, the runoff discharge Q is equal to 0.44 into 40 by 1000 into 200 into 10 to the power of 4 divided by 3600. On solving this, the runoff discharge Q is equal to 9.778 meter cube per second. So option B is the right answer. Question number 70. The radius of horizontal curve is 100 meter, the design speed is 50 kmph and the design coefficient of lateral friction is 0.15. The super elevation required if full lateral friction is assumed to develop is. So we have to find the super elevation for full lateral friction. As per IRC, we know that the formula E plus F is equal to V square by 127R. E is the super elevation we have to find. F is the coefficient of lateral friction 0.15. V is the design speed 50 kmph, so 50 square divided by 127 R. R is the radius of horizontal curve, that is 100 meter. So if you calculate this, E will be 0.0468. Therefore, the super elevation is 0.047. Option A is the right answer. Question number 71. The degree of horizontal curve of radius 100 meter based on 30 meter chain. For a 30 meter standard chain length, the degree of horizontal curve is given by the formula D is equal to 1718 divided by radius of horizontal curve. Therefore, 1718 divided by radius of horizontal curve is 100 meter. So, if you solve this, degree of horizontal curve will be 17.18 degree. So, option A is the right answer. Question number 72. A tachometer has a multiplying constant of 100 and no additive constant. The stadia readings at station B with axis horizontal are 2.048, 1.524 and 1. These are the upper, middle and lower readings. The horizontal distance between the tachometer and the station B is. So to find the horizontal distance between the tachometer and the station, we know that the formula D is equal to Ks plus C, where K is the multiplying constant 100 and C is the additive constant 0, since they have not given the additive constant, and S is the stadia readings between the upper and lower readings. This is the stadia readings. Upper reading is 2.048 and middle reading of the stadia is 1.524 and lower reading of the stadia is 1. S is the difference of the upper and lower stadia readings, that is 2.048 minus 1.0. So difference of stadia is 1.048 meter. If you substitute these values in the above equation, that is D is equal to 100 into 1.048, the horizontal distance between the tachometer and the station B is 104.8 meter. So option A is the right answer. Question number 73. The depth of critical neutral axis in limit state method for a rectangular reinforced concrete section having an effective depth of 500 mm and FE 415 bar is, as per IS 456-2000 codal provisions, for a grade of FE 250 steel, the critical depth is given by 0.53 times of depth and the limiting moment is given by 0.148 FCK BD square, and for FE 415 steel grade, the critical depth is given by 0.48 times of D and limiting moment is given by 0.138 FCK BD square. For Fe 500 grade of steel, the critical depth is 4 times of the depth and limiting moment is 0.133 FCK BD square. In the given question, they are asking for Fe 415 steel grade. So, the depth of the critical neutral axis XU limb is equal to 0.48 times of depth of the section. So, 0.48 times of 500. Therefore, the critical depth will be 240 mm. Option A is the right answer. Question number 74. A laced steel column is designed to carry an axial load of 500 kN. The total transfer shear to be resisted by lacing is. The total transfer shear resisted by lacing is 2.5% of total axial load. That is equal to 2.5 divided by 100 multiplied by 500. 100 ones are 100 5s are. Therefore, 12.5 kN is the total shear resisted by lacing bar. So option B is the right answer. Question number 75. The plastic modulus of a section is 4.8 into 10 to the power of minus 4 meter cube. The shape factor is 1.2. The plastic moment capacity of the section is 120 kN meter. The yield stress of the material is. So we have to find the yield stress of the material. We know that yield moment is given by the ratio of plastic moment divided by shape factor. Plastic moment is 120 kN meter divided by shape factor is 1.2. Therefore, the yielding moment will be 100 kN meter. And yield section modulus is given by plastic section modulus divided by shape factor. Plastic section modulus is 4.8 into 10 to the power of minus 4 meter cube divided by 1.2 is the shape factor. So, the yield section modulus is 4 into 10 to the power of minus 4 meter cube. Now we have to calculate the yield stress of the material, and yield stress of the material is given by the formula sigma y is equal to, it is the ratio of yield moment divided by yield section modulus. Yield moment is 100 kN meter. 100 divided by yield section modulus is 4 into 10 to the power of minus 4 meter cube. If you calculate this, the yield stress of the material will be 250 MPa. So option C is the right answer. This completes the part 2 questions of this question paper. I hope all the information and the solutions provided for this PGCET 2010 question paper is satisfied for your preparation of PGCET examination and other civil engineering competitive recruitment exams. Thank you for watching this video.